So during this topic we're going to look at some qualitative analysis. So this involves testing for inorganic ions to see which ones we have in solution, and that will help us identify the compound that's in solution. So first of all, we'll recap a few of the tests that we can do. The first one is to test for the carbonate ion, that's CO3 2-. Now, as you'll know, carbonates will react with acids to produce carbon dioxide gas. So if I have a carbonate ion in solution, if I add some nitric acid to the solid or the solution, I will see bubbles of carbon dioxide gas produced. If I want to be doubly certain, I can bubble that gas through lime water, and if it is carbon dioxide, I will see a white precipitate of calcium carbonate form. And those are the two equations on the slide there. The next test is for the sulfate ion. So for this one, we add barium chloride or barium nitrate solution to a solution of the compound being tested. And now if sulfate ions are present, that's SO4 2-, I will see a white precipitate of barium sulfate produced. So that we use barium 2+ ions to test for sulfate ions. Finally, for the anions, we're going to look at halide tests. Now, the halide tests were covered in the group 7 topic, but let's just recap for that. For this one, we add silver nitrate solution to a solution of the unknown compound, and we will, if we have a halide present, we will form the silver halide precipitate. Now, often these silver halide precipitates are of a similar colour. If I'm testing for a chloride, I would make silver chloride, which is white. If it's bromide, I make silver bromide, which is cream. And if it's iodide, I make a kind of pale yellow precipitate of silver iodide. So in order to distinguish, we add aqueous ammonia solution to test the solubility of the precipitate. And so on the next slide, we will just have a look at those equations and colours of the precipitate. So as you can see, I've detailed the colours of the precipitates there, and also the solubility of the precipitate in ammonia solution. Silver chloride will dissolve in dilute ammonia, silver bromide will be soluble in concentrated ammonia, and silver iodide is insoluble. Just as a note of interest, you may be wondering why we can't test for fluoride. That's because silver fluoride is actually soluble in water, so you wouldn't see a precipitate if you had fluoride ions present. And that's why we can only test for chloride, bromide and iodide as the halide ions. So let's say I've now got a test tube with a unknown solution in. And I've only got that one test tube, and I've got to decide whether it contains carbonate, sulfate or a halide ion. So what would I do first? Well, the first ion I would test for is the carbonate ion, and I would add my dilute nitric acid for that. If I see bubbles, then I can tell it's a carbonate present. And that's because neither sulfate or halide will produce bubbles with an acid. So let's say I don't see any bubbles, so which one am I going to move on to next? Well, the next one I would test for is, I would test for sulfate. So for that one, remember we add barium 2+ ion, so either barium chloride or barium nitrate. And we would make barium sulfate, which is a white precipitate if it's present. Now, the reason why we've had to do sulfate after carbonate is I've had to eliminate carbonate first, because if I added barium ions and it contained a carbonate, I would make barium carbonate, which barium carbonate is a white precipitate. So if I just added barium chloride first of all, I'd see a white precipitate, but I wouldn't know whether that white precipitate is due to barium carbonate or barium sulfate. Right, so let's say I don't see a precipitate. What one am I going to go on to next? Well, now I'm going to test to see which halide I've got there. And again, I have to do halide first because both silver carbonate and silver sulfate give me white precipitates in water. So again, if I added silver nitrate first of all, and I see a white precipitate, I wouldn't know whether it's silver carbonate, silver sulfate or silver chloride, which I've made. Okay, so because I've done this one last, I've eliminated carbonate and sulfate, and therefore I'm just testing to see whether I've got chloride, bromide or iodide there. So remember, carbonate, then sulfate, then the halide test. Now let's say I've been given a test tube and it contains a mixture of anions. How am I going to tell which mixture I've got? Well, you do the tests in the order that we've just discussed. So the first one I'm going to do is I'm going to add nitric acid, and I keep adding nitric acid until all the bubbles have stopped. If I do see bubbles, that's removed all the carbonate ions. So if I've seen bubbles, I say, okay, I've got carbonate there. If I don't see bubbles, I can move straight on to the tests for sulfate and halide. So I've done that, and I'm now going to add excess barium nitrate solution. Now, as I add the barium nitrate, remember, note here, I am not adding barium chloride solution. Because if I did barium chloride solution, that would put chloride ions in there, and I want to test for chloride later on. So I add barium nitrate, and any sulfate ions will precipitate as barium sulfate. So let's say I see a precipitate, I say, okay, well I must have sulfate ions there, and now I want to test for chloride, bromide and iodide. So I've got to remove that white precipitated barium sulfate, so I filter it off. And that's removed all my sulfate ions. Okay. And once I've done that to the filtrate that I've just produced, I would then test to see which halide I've got. So I would add silver nitrate, and then if I see a precipitate, I would add ammonia solution to tell whether in the filtrate I've got chloride, bromide or iodide present. So first of all, test for carbonate, then test for sulfate, and then to the filtrate, if you do get a precipitate, you need to test for chloride, bromide and iodide. Finally then, just a little reminder about how we test for positive ions. So the one cation you need to be able to test for is the ammonium ion. And the way you do this is to the solution you add sodium hydroxide solution. And if ammonium ions are present, you will produce ammonia gas. Now you're not going to see that because ammonia gas is soluble in water. So you add the aqueous sodium hydroxide solution and warm it, and then you test the top of the test tube with some pH paper, because you will get ammonia produced, but you won't get enough ammonia produced, you will see bubbles. So you need to test the top with pH paper, and if you test the top and it is alkaline, you know that you have produced ammonia gas and the pH paper will go blue.